So, the unit circle. What is it? Why do we need to know it? And what are we going to be expected to do with it? Um, First, know that it's a circle along the rectangular coordinate grid, so the normal grid that we're used to graphing in. Um, it has a radius of 1. Okay, and that's a really important piece of this. Okay, and that's kind of why, if you remember the lesson we just went over, why sine of theta being y over 1, why I picked that radius to be 1. Okay, it's a really helpful tool for trig. So one way that I've kind of explained this is in elementary school, you spend a lot of time memorizing your multiplication facts, right? Which some of us are really good at, some of us that wasn't our strong suits, but it is really important to have kind of that basic number sense to work with algebra. Think of knowing the unit circle as kind of knowing your multiplication facts, but for higher level math. So for being able to use pre-calculus and eventually calculus. Okay, so knowing all these things along the circle are going to help you really help you calculate values of sine, cosine, tangent fairly quickly without the use of a calculator. Okay, so really important thing moving forward. Don't worry about jotting this down now because I'm going to give you a full copy that we're going to fill in together here in just a minute. Okay, so it's made up of special right triangles. Let's come back to this here in a second and let's work on filling in the unit circle with degrees and radians. Let's do that right now. Okay, so I'm going to hit pause here. So some parts we already know on here. Right now, we're just going to worry about filling in the angles, and then we'll come back and do the points later. Okay, so right now, we know, and again, remember when we first started this lesson, we were drawing angles, right? And we drew them in what was called standard form. So when we're out at the positive x, we have done no rotation. So that's 0 degrees. That's what you're going to put next to the degree symbol. And then that's also 0 radians. So the radians go next to the degrees there. Then one of the very first facts that I told us that we should know, this is how we converted degrees to radians, is that the straight angle here, so a straight angle is 180 degrees, which is equal to pi radians. So if we know this, we can kind of use fractions to find the rest of these values. And here's kind of what I mean. This 90-degree angle or right angle formed by the positive x and positive y, that's 90 degrees, right? That's clearly a right angle. And so what I think about is 90 goes into 180 how many times? 2, making this pi over 2. Now, here are ones that we don't really know quite yet, and I'm going to talk about where these come from. They come from special right triangles, so from the 30, 60, 90, and 45, 45, 90 triangles. And I am going to draw those in for us when we do the coordinates here. So this first angle is 30 degrees, followed by 45 degrees, followed by 60. And so all other degrees and radians are increments of these values of 30, 45, and 60, just from that previous kind of reference spot or reference kind of point. And those reference points being the axes. Okay, so using the axes, we can kind of think our way through these. Now, here's how I do the radian conversions. I don't take 30 degrees and do the full conversion in my head. I instead think about how many times does 30 go into 180? And that'd be 6. So meaning this is 1/6 of the way to pi, making this pi over 6 radians. Then I'll do the same thing. How many times does 45 go into 180? That would be 4, making this pi over 4. It's 1/4 of the way to pi. Then 60 degrees goes into 183 times, so it's 1/3 of the way, making it pi over 3. Moving forward, and I'm going to touch on this once. We have 1. So this whole quadrant here. You can use that to build all other quadrants. So here's kind of a way to do that. Again, I know just kind of previously that this right angle is 90 degrees. And so to fill in my degrees here, I can take 90 and then just add increments of 30, 45, and 60 to it. So 90 plus 30 is 120. 90 plus 45 is 135. 90 plus 60 is 150. And now for the radians, again, there's lots of ways of how we can kind of think about these radians here. I'm thinking about 120, okay, how many times, I'm kind of reducing it 120 to 180. I might also think about using some of these values in quadrant 1. What is it a multiple of? Well, and I want to use the biggest value. It's a multiple of 60, right? It's one extra 60-degree rotation from what we did previously. So we've done two 60 degrees, which are 2 pi over 3s, making this 2 pi over 3. Okay, it's 2/3 of the way to pi. Okay, the 45 degree, well, we did 1 pi over 4. Another pi over 4 is what gets us to pi over 2. So this is 2 pi over 4 plus an extra pi over 4 is 3 pi over 4. And then 150, that's actually an increment of 30. It's not an increment of 60, so this is 1 pi over 6. This would be 2 pi over 6. This would be 3 pi over 6, which reduces down to pi over 2. 4 pi over 6. 5 pi over 6. There are a lot of ways of how you can go about filling in the degrees and radians. Find a way that works for you. A lot of patterns. Some people pay attention to the denominators. It goes 6, 4, 3, 2, and then 2, 3, 4, 6. Okay, so there is some patterns there with what the denominators are. You can kind of decide. Now, once I have these top 2 quadrants filled out, I then use the fact or the idea of a straight angle, where I know that this angle down here in quadrant 3, this first one, is 180 degrees or straight across from the 30. So 30 plus a straight angle of 180 is 210. So I do the same thing with the radians. Pi over 6 plus a straight angle, which is pi. So pi over 6 plus pi, well, that's 6 pi over 6 plus one more pi over 6 is 7 pi over 6. And I'll do that same thing with 45 degrees. So 45 plus 180. Or, yeah, we're basically doing what I did before, right? This 45 plus the 180 is 225. And then pi plus pi over 4 is 5 pi over 4. And real quickly, why don't you fill in the rest of the degrees and the radians? So here are last values. Just go ahead and double check that these are all correct. Don't forget about the negative y-axis. At the negative y, we're at 270 degrees. So that's a right angle plus 180, making that 270. Or pi over 2 plus pi, making the radians 3 pi over 2. And then again, you can just kind of check the others. Again, lots of ways of how you can go about filling this in. You need to find a way that works best for you. When you get to pre-calculus, you will be expected to have this whole thing memorized and able to recreate it. It seems like a big task because of how many things are on here, but once you start to see all the patterns, you realize that it actually isn't all that bad, okay? I think more than likely in this class, we're going to provide it and just kind of understand how to use it, and we won't really worry about having it memorized quite yet. But if you want to kind of get a head start for the work you'll do next year, get familiar with this unit circle, okay? It'll really kind of help you as you progress forward. All right, questions about any values that I have on here? Okay, so let's start to fill in the coordinates, okay? Now, we've already, so let's go back to our math notebooks. And all the coordinates on the unit circle stem from our special right triangles. And the reason they stem from the special right triangles, well, think about the values that we were just using, right? The unit circle are increments of 30, 45, and 60. The exact same rotations in those special right triangles. So what I have here are the ratios from those special right triangles that you have in your notes from a previous lesson. So what I want us to do is fill these out for what the unit circle will be. And one thing that we know, so let's pretend that I'm going to take this 30 degree here. If I draw this triangle all the way out and drop it down, I've formed a right triangle with this being 30 degrees. Knowing that the radius is 1, what does that make the hypotenuse here? 1. In the unit circle, the radius is always 1, and with any triangle we create, the hypotenuse is 1. So this allows us to solve for x to then come up with special right triangle values for all of these. Okay, so x root 2 equals 1, making x equal 1 over root 2. Well, we can't have square roots in the denominator, so I'm going to multiply by root 2 over root 2, which is root 2 over 2. So for the exact triangle that we're going to use in our unit circle, it's 45 degrees. 45 degrees. The radius is always 1. And with the side lengths being equal and equal to that value of x, they're both going to be root 2 over 2. Okay, now let's find these same values for the 30, 60, 90. In the 30, 60, 90, the hypotenuse is equal to 2 times whatever our variable is. So 2x equals 1 makes x equal 1/2. So now for this 30, 60, 90, the hypotenuse is 1. The shorter side is equal to just x, so 1/2. And the longer side is x, so 1/2 times root 3, which is root 3 over 2. And so we're going to use those values, okay, to find these points. And so just like what we had learned last class or in the last lesson, the horizontal leg is your x coordinate. The vertical leg is your y coordinate. Okay, so at all coordinates around our unit circle, we're going to have really one of 3 values. Root 2 over 2, 1/2, or root 3 over 2. Everyone follow me there? Now, here's what I really pay attention to and focus on. I think about the size of these numbers, okay? And of root 3 over 2, root 2 over 2, and 1/2, what's the biggest value and what's the smallest value? Well, root 3 over 2 is the biggest of those 3 values, followed by root 2 over 2, followed by 1/2. So this is the biggest number, root 3 over 2, 1/2 is the smallest. So knowing that, when I go to my unit circle and I start to fill in all the coordinates, again, I think about, okay, since I know that my coordinates are going to be one of these 3 values, I think about how far over and how far up am I going to go? Am I going over by the largest amount, so root 3 over 2, the middle amount, or the smallest amount? And am I going up by, again, same question, the largest, middle, or smallest amounts? Okay, so here's what I'm referring to. At 30 degrees, this point here, I'm having to go to the furthest to the right of any other point in quadrant 1. Right? All other points here, I'm not going as far right as I needed to. So this horizontal leg is the biggest of the 3 values, which is root 3 over 2. The middle amount is the value right in the middle. That's root 2 over 2. And then the x value that's the shortest is this one at pi over 3 because I'm having to go right by the least amount, making that 1/2. So then for the y coordinates, I use the same logic. Okay, which one of these values am I going up by the most, the middle, and the least? At 30 degrees or pi over 6, I'm going up by the least amount, right? That's the furthest up that I need to go. So I'm going to use the smallest value or smallest coordinate being 1/2. Then root 4 or pi over 4 is the middle amount, root 2 over 2. That's the middle amount of how far up I'm going. And then the last one, pi over 3, I'm going up by the biggest value, which is root 3 over 2. Okay, and again, we see some patterns here, right? Root 3 over 2, root 2 over 2, 1/2. And the y's are just the opposite. The root 2's over 2's will always be paired together. Okay, and so as we use these coordinates in other quadrants, they're the exact same. We just have to change the signs based on which quadrant we end up in. Now, the only other thing that we don't have here that kind of stems from our lesson from last time are the values and coordinates at the axes. Well, at this axis here, I'm going right by a full radius amount. Wouldn't you all agree that from here out to here, that's the radius, making the x-coordinate 1, and I'm not going up or down at all, so making the y-coordinate 0. And then up here at 90 degrees, I'm going straight up by a radius amount. So the y is 1, and I'm not going over at all, so that's 0. And then now, let's think about how we can kind of use these coordinates over here. Okay, with quadrant 1's, I can basically just copy these same coordinates for each value, and I'll come back and change the signs. So 1/2, that's this x-coordinate at 2 pi over 3. Y is root 3 over 2. At 3 pi over 4, that's root 2 over 2. And then at 5 pi over 6, it's the same coordinates at pi over 6, where x is root 3 over 2 and y is 1/2. But in quadrant 2, x is negative. So all these x coordinates are negative. All right, real quickly, go ahead and add in the coordinates for the rest of the unit circle. We'll check this, and then we'll start putting this to use. All right. So again, your coordinates, all same values, just a matter of changing the signs. Don't forget about at pi and 180 that your coordinates are -1, 0. Then you can check them in the given quadrants. Down here, x and y are both negative, so make sure you're filling them in as negative. And then down at 3 pi over 2 and 270, y is -1, x is 0. And then again, over here in quadrant 4, the y's are negative, the x's stay the same. Now, the last thing that I want us to fill in here is you see these positives, negatives. That's referring to the given trig functions. So in which quadrant are each trig functions either positive or negative? So let's just go around and fill that in, kind of adding in from our lesson previously. So where each trig function is either positive or negative. So since I'm down here, I'll just go ahead and start with quadrant. This is 4. In quadrant 4, that's again all students take calculus. So my positives are the calculus. So the cosine and its reciprocal, which is secant. All other trig functions are negative. So that'd be sine, its reciprocal cosecant, tangent, cotangent. Okay, while we're at it, let's use quadrant 3. So all students take. So the take is the tangent and cotangent are positive. And then all others are negative. So sine, cosine, and their reciprocals. So cosecant and secant. And then up in quadrants 1 and 2. 1, I'm just going to say all positive, none negative. That's quadrant 1. Quadrant 2 here. That's all students. So the positive is the student. So sine and its reciprocal of cosecant. And then all others. So cosine, secant, tangent, and cotangent are negative. All right, so this is like your calculator for the rest of this lesson and for the homework that you will have following this lesson. Okay, everything that we work with is going to correspond to values on the unit circle here. Any questions about the unit circle, though, before we kind of start to do some work with them? we are going to continue to use SOHCAHTOA to find these values. You're going to kind of see some patterns that I'll touch on as we go through this. But SOHCAHTOA is a way to find all of our values at given angles around this unit circle here. All right. So right now, let's put this to the side as we'll use this. I'm going to come back to that. Okay, to answer some problems. So the first problem is actually very similar to the work that the lesson we had just finished, where we're going to be given a specific point, and our task is going to be to find the 6 trig values at that specific point. Our work does not change, okay? But one thing that's nice is that coordinate P is going to end up being on the unit circle. And there's a couple ways of how I can tell that. Okay, one being these coordinates. So 1/2 and root 3 over 2, I recognize that as being coordinates on my unit circle. If I were to go ahead and let's draw this real quick actually. Okay, so by drawing this, x is negative, y is positive, so it puts us over here in quadrant 2. And this is that point. We've rotated an angle of theta. And so again, I can create a triangle here where x is negative 1/2, y is root 3 over 2. Now, if I were to use the Pythagorean theorem, I'm going to save us some time in this, we're going to find that the hypotenuse is 1. And that's what tells me I'm on the unit circle. The other thing is, again, these coordinates here. If I look at my unit circle where I have negative 1/2 and root 3 over 2, I could even figure out what theta is, right? Theta in degrees is 120 degrees because of the coordinates we get based on that rotation. Or if we're working in radians, 2 pi over 3. Okay, but I actually don't need to know what theta is to answer this question. It's just like the work we did before where we're going to find sine, cosine, and tangent of these values. Now, this is going to bring up another kind of important thing on the unit circle that I kind of touched on previously. So let's go ahead and do sine of theta, cosine of theta, and tangent of theta. And let's use what we know about right triangles. So let's use SOHCAHTOA. So sine being the opposite side, root 3 over 2, divided by the hypotenuse, which is 1, is root 3 over 2. Now, if I look at this, remember that this horizontal leg, that's equal to the x-coordinate on the unit circle, and the vertical leg is equal to the y-coordinate on the unit circle. So what can I conclude? Sine of theta is equal to what value on our unit circle, or which coordinate? The y. When we're working in the unit circle, that is always true. You don't even need to use SOHCAHTOA. You can just say sine of the angle theta is the y-coordinate. Boom, we're done. Let's see how that works for cosine. Cosine being the adjacent side, so negative 1/2 over the hypotenuse of 1 gives me a value of negative 1/2. Which coordinate is that equal to? X. On the unit circle, cosine of the angle is always the x-coordinate. Tangent of theta is the opposite side, so root 3 over 2 over the adjacent side, negative 1/2. And I know that root 3 over 2 is y, negative 1/2 is x, making tangent equal y over x on our unit circle. Now, this needs simplified, so let's simplify that before we actually give the value here. So this is root 3 over 2 times 2 over negative 1. The 2's divide out, and we get negative root 3. Okay, so tangent almost always has us doing some kind of simplifying. Okay, now let's see the reciprocals. So cosecant of theta. Well, if sine is y, what would the reciprocal of y be? 1 over y. if I were to flip that. Secant of theta is 1 over x, and cotangent of theta is x over y. And all I'm getting those values from is taking the reciprocal of these coordinates here. So 1 over the y coordinate is 1 over root 3 divided by 2, which is the reciprocal of that. So that's 2 over root 3, which then needs simplified by multiplying by root 3 over root 3, which is 2 root 3 over 3. Secant is 1 over x, so 1 over negative 1/2, which ends up being just negative 2. And then cotangent is negative 1/2 over root 3 over 2. So to simplify, it's negative 1/2 times the reciprocal of 2 over root 3. So I get negative 1 over root 3, which then needs simplified at root 3 over root 3. So this is negative root 3 over 3. Okay, questions here? All right. I want to do some of the problems so that way we can get you started on your assignment. Keep in mind this assignment I'm going to have due on Monday, so I'm going to give you plenty of time to kind of chip away at it. But let's do problems that are directly related to the unit circle, because with this, we actually didn't even need to use a unit circle. Okay, we could have found those values just by using what we already knew about trig functions and angles. Okay, so here are the problems that you're going to be doing more on the unit circle. Now, there's two ways of how we can go about doing them, and I'm going to share two different ways, okay, or both of those ways. So it says use the unit circle to find the exact value of the following. So here's how this works. Cosine of 30. I'm going to find that unit circle. I'm going to rotate to 30 degrees. Boom. Okay, at 30 degrees, I can either use the triangle. Okay, so I could just kind of recreate that triangle there. So 30 degrees, where the x was root 3 over 2. Let's try that again, Mr. Youngren, root 3 over 2, and the y was 1/2. The hypotenuse is 1. And so if I take the adjacent side of root 3 over 2 over the hypotenuse, 1, I just get root 3 over 2. I could have also used what we just came up with in that cosine of theta is equal to the x-coordinate. And I didn't even need to do that work. And that's going to actually be a much quicker way to do this moving forward. So how about sine of pi over 4? I'm going to go to pi over 4. Sine of pi over 4 is the y-coordinate, which is root 2 over 2. Done. Tangent of 3 pi over 4. Once again, I'm going to grab this unit circle. I'm going to rotate to 3 pi over 4. I need to take y divided by x. I'm recognizing that y and x are the same values, and anything divided by itself is 1. One of these coordinates is negative, though, making that negative 1. We all seeing where these come from? Why don't you just, for your own practice, do D, E, and F, and we'll close it out there. Okay, take a minute to do D. Okay. So for those last values, what did we leave off on? D, that's root 3 over 2. E is another, again, root 3 over 2. Cosecant of 5 pi over 4. Well, I remember that cosecant is a reciprocal of sine. So instead of being the y-coordinate, it's 1 over y. That needs some simplifying because it's 1 over negative root 2 over 2, which simplifies to just simply negative root 2. Okay, that does it for this lesson.